So the next type of scenario that we could have is either an addition or subtraction problem that has both a positive and a negative integer. So let's go ahead and deal with this first example. How about we do 5 minus 7, okay? So the first thing that we see, obviously this 5 is positive, so I'm going to go ahead and gather up 5 of my positive algebra tiles. And it looks like I accidentally grabbed a 6th, so let me get that back. But now I can actually turn this, turn this into an addition problem and put the negative with the 7. The negative was with the 7 anyways, but making it plus a negative sometimes just helps my brain see it a little clearer. So now I'm going to go ahead and gather up, remember those red tiles represent the negative integers. So let me bring down my negative 7. And now we need to introduce a new term, because since we have both black or positive algebra tiles and red or negative algebra tiles, we can form what are called zero pairs. Now, zero pairs are a pretty basic idea if you've ever had like a dollar bill. So you have a dollar in your pocket, and let's say that there's a candy bar that you really want. Well, you have to spend or you have to lose that dollar. So a positive dollar and a negative dollar, if that's all you've got in your pocket, well, right now you've got nothing. So it equals 0. That's the key with a zero pair. So what I'm going to do now is I will rearrange my algebra tiles so that I have all of the positives lined up with a negative. Whoops. And that will help show us the zero pairs. I've got 2 more here that I can use, and then I'll take these 2 red ones. So what's going to happen now is if I have a positive algebra tile and a negative algebra tile, those cancel or create a zero pair. Then the next positive and the next negative will also create a zero pair. So on and so forth, every single grouping of a positive and a negative adds up to 0. So I have just eliminated all of the zero pairs, and what I have left is my answer. So this is all that I have left. Notice there are 2 algebra tiles, but they are both red, which means they're both negative. Therefore, 5 minus 7 equals negative 2. Let's try that again. This time, let's do a subtraction problem. So I'm going to start with now, how about negative 3 minus a negative 5? Okay. Now, the first thing that we see is a negative 3, so obviously that is negative. But here, this is a really interesting situation. When I have minus a negative, what this is really asking you is to do the opposite. And we know that the opposite of a negative is actually creating a positive. So this now turns into a problem, negative 3 plus a positive 5. So once again, if it's minus a negative, that means do the opposite. Minus a negative will turn into a positive. So now I'll grab the algebra tiles that I need. That'll be negative 3, so 3 of the red tiles, and 5 of the black tiles. Now, I won't take the time to line them up as much as I did the last time. I'll just go ahead and show you that this red and this black will pair up as a zero pair, so those are eliminated. This negative and this positive pair up, that's a zero pair. Red, black is a zero pair. So I have canceled out, or those 3 pairs have added up to 0. Therefore, my final answer is only the pair of 2 black tiles that are left. So my answer for the problem negative 3 minus a negative 5 is actually a positive 2.